Hello everyone and welcome to this new tutorial of Plaxis. Today I'm going to do the second tutorial in the tutorial manual of Plaxis. It's an excavation in sand. It consists of a shoring system. Okay, so this shoring system is formed of sheet piles with strut in betweens, and in the small part of the excavation there will be anchors. So what we will learn in this tutorial? We will learn to use the hardening soil model. I made a previous tutorial about the soil model. Now the link will appear on the screen. And we're gonna learn about how to model anchors, interface, defining over consolidation ratio, pre-stressing a grout anchor, changing water condition, selection of stress point to generate stress, and viewing plastic points. So I'm gonna leave also a link to this tutorial, to the manual, in the description box. This is our excavation. It's formed of four uh, four soils. There's the fill, the sand, soft clay, and sand. So these are the level of the soil. So first of all, we're gonna start a new project and model the materials. So I modeled the materials previously to spare some time from this tutorial. And this is the limit of our contour, 18, 80, and 50. I put it here, so I press OK. So I'm gonna create a borehole. So here we can see there are four layers: -1, -9.5, -11, and -20, with the head in the borehole is at -4. So I'm gonna draw these layers. Okay, so the first one will be 0, -1, -1, -9.5, -9.5, -11, -11, -20. So I created the materials to spare some time. The first one is fill, sand, soft clay, and also sand. The borehead is -4. The waterhead, I'm sorry. And press OK. This is the layers of our project. So now we're gonna go to structures. Okay, so it's finished. I modeled these material. We've modeled them previously in 3 tutorials, so I'm not gonna do it right now. I'm gonna start by drawing the elements. So as I said earlier in other tutorials, drawing 2D is much easier than 3D. For example, here we have a surface. It consists of 4 points. When modeling in 2D, we only have 2 points. We can draw it a line. So that's why whenever you have something that you can do it in Plaxis 2D, just go for it. So I'm gonna start by creating a surface between these 4 points. I'm gonna go to surface, press 4 points. I'm gonna put them here: 30, 20, okay, so this is our surface. I'm gonna press OK. We've drawn the surface. Now we're gonna extrude it 3 times, from from 0 to -1 to -6.5 and to -11. -1. I'm gonna press on the surface. -6.5. And -11. So we're gonna do 3 soil volume. It's for the excavation later on. There will be 3 phases of excavation. So we're gonna create the volumes. We did it. We're gonna right click on the biggest volume and decompose it into surfaces. We're gonna delete the top surface and the surface we created before, and we're gonna hide all the other excavation volumes. So this is the biggest volume, decompose into surfaces. I delete the first polygon and then the second. And now I'm going to go to geometry, volumes, okay. So this is the first, the second, and the third volume. Okay, so now we're gonna create beams. These beams will be on the wall. They are supported. They are supported by the wall, but they transfer the forces from the struts and the anchors to the wall. So first of all, I'm gonna create a beam. So here we can draw it. You're gonna draw it at -1 and these 4 points. So to do that, I'm gonna press on shift. When I press on shift, I only go through the Z axis. When I remove my hand, I'll stay in this plane here. So I'm drawing the beams now. It's done. Now we drew the wallings. Now we're gonna create the struts between these points. So I'm gonna draw a beam another time. It's between these 2 points. And -1, 32, and -1. So this is the first strut. So to draw the other, I'm gonna do an array to draw 2 other struts at x equal 40 and x equal 45. So there's 5 meters between these struts. I'm gonna go to array and x direction 2 and distance is 5. This is the first one. So I'm gonna undo it and create 3 and press on 5. Okay, so these are the struts here. For the material, these are the materials of the beams. I made them earlier also to spare some time because we modeled a beam before. So now I'm gonna give the material to the struts. Beams, material, strut. These 4 beams. I'm gonna assign the material to them also. Okay, so it's done for the beams. Now we have to model the anchors. So what is an anchor? An anchor consists of a grouty body that takes the forces and transmit it to the soil, and an anchor that transmit the forces from the wall to the grouty body. So we're gonna draw a node-to-node anchor at this point here. So this is a node-to-node anchor. These are the coordinates. So this is our first anchor. We're gonna create a node-to-node anchor between these 2 points also. Okay, so I'm gonna redraw this beam. The second node-to-node anchor between these points. -7. So this is the second anchor. So now we're gonna create the grouty bodies in between these points. So it will be an embedded beam. I'm gonna press any 2 points and then assign them here. I'm gonna create also another one. Sixty, 24, 62. Now it has its shape. So it's finished for the grout part of the anchor. So now we're gonna create a material for the node-to-node anchor. We're gonna go to anchors, new, okay, it's elastic. Here we're gonna put it to 6.5 E10. So I took it here from the material. I've created the grout previously. So now we're gonna assign the material grout. So these node-to-node anchor are formed from cable. They will be post-tensioned. So now we're gonna create a second node-to-node anchor by the array command. We select them all, array in the y direction, So now we're gonna select them and create the group. Uh, so now we've created this group. It's formed of the anchors. So this is the group I want. I want a group for all 8 parts of the anchors. So we're gonna go and name the group ground anchors. Double click on it. So it's created. Now we're gonna create the sheet piles and create plate. So these are the properties of the sheet pile. They have thickness equal to 0.3 meters. Okay, so they are not isotropic. They have different properties in different direction. So this is why you should take in consideration the axis later. So if you can see in the small side, we can't put a strut in all this distance. This is why we put anchor here. In the small direction, we can put beams. This is why this is the shape of the excavation. Okay, so we're gonna press on the surfaces and create plates. We're gonna assign the material, sheet piles. We're gonna create a positive interface and create a negative interface. Okay, so there's only left to draw this load. You're gonna draw a surface load between these 4 points. You're gonna go to surface load. You're gonna put any 4 points. It's 0, 0, 0, and 0. And the points are 34, 18, so this is the surface load. So we're gonna now make sure to change the axis of the sheet pile. So this is it. We're gonna go to the model explorer and go to axis function. So it's automatic. We're gonna put it manual and put -1 here. So when we go to option show access on surfaces, we can see that the blue one is always for the outside. It's the Z axis, the Z axis. So we finished our structure. Now we're gonna generate a mesh. Okay, so here we're gonna put the to coarse. We're gonna change it to coarse. Okay, so this is it. Press OK. So now we can see our structure. Then we assign a material. Okay, so the beams are erased node to node. We're gonna recreate them. I'm gonna set the material to node to node. I'm gonna recreate our mesh. So now it looks fine. These are the struts here. We can proceed to staged construction. So we're gonna here create 6 phases. The first one will be the initial phase. We're gonna create a second one. So in the next phase, we will install the sheet piles and the interfaces, and we're gonna remove the first soil. In the second phase, we're gonna put the beams. We're gonna make a third phase. In the third phase, we're gonna activate the ground anchors. In the final phase, okay, so here I forgot to pre-stress the anchor. Okay, so here we can see that we should pre-stress them to a value of 200 kilonewtons. Okay, so in phase 4, we will proceed the further excavation. Okay, so now it's finished. And we're gonna leave the last phase will be the apply of the load. We're gonna apply the load in this phase, surface load. I'm gonna put the value of the load. It's let's see the load. Okay, so we're gonna apply it later. We're gonna proceed to calculation. I'm gonna put the pause on the video to save some. So the calculation is finished. Now we can see the results. So here we're gonna view the results. First of all, we're gonna see the steady pore pressure. So for that, we're gonna make a cross section here at these points. So it will be here, let's say 21, 29, 25, and 25, 20, or 30. So here you see the deformation. I'm gonna go to stress, pore pressure. It's the steady state. So here you can see the pore pressure. You can define the X here by manually. Value 0. Maximum value 0. Number of intervals 18. Okay. So this is it here. So now we're gonna close it. I'm gonna assign to the load a value. It will be minus 20. So I'm gonna launch the calculation another time. Okay, so this time I'm gonna put I'm gonna define the point. Okay, so it will be this point here. Okay, so it's 37.5, 19 minus 1.5. So I'll choose this one. So we're gonna launch the calculation other time. I'm gonna pause the video also. So it's finished. Now we're gonna see the stress points. I'm gonna go to plastic point. Now we can see the plastic points created. Here we're gonna go to view, viewpoint, top. Okay, so these are the plastic points in our model. And now we're gonna also create a curve. So we're gonna go tools, curve manager, new. Okay, the deformation, total strain, we're gonna choose this one. And here is stress. I'm gonna press on OK. So now we can see the curve. You can generate any curve you want. So I'll be attaching this PDF. You can generate the curves in the PDF. Thanks for watching. If you can please subscribe to my YouTube channel. Thanks.